Hi, this is Mr. Phillips, and I'd like to talk to you about Activity 8.1 Modified. This is the investigation where you took 5 grams of cupric chloride, added it to 50 milliliters of water, and then added 0.5 grams of shredded aluminum foil and made your observations. Some example data is listed for you here to see what temperature changes you may have had. The initial temperatures are in the first column, temperature after immersing the foil is in the second column, and the third column shows you the temperature changes. I'm going to use the average of 30-degree temperature change in my discussion here. This may have been one of the byproducts you saw after you got done with this chemical reaction, and you will find out later that the material that you have in here is indeed copper from the cupric chloride solution. So you were supposed to answer some questions along with this activity. So the first question says, what did you observe? So this would be quantitative data. So you may have observed that the temperature increased from 22 degrees Celsius to 52 degrees Celsius in my instance, giving me an increase of 30 degrees Celsius. So that's numbers because it's quantitative, which is quantity. What else did I observe? Well, qualitative observations may have looked something like this. The solution turned color from blue to grayish purple. You may have seen bubbles, and you may have noticed the vapor. If you smelled that vapor by wafting safely, you may have noticed it smelled like chlorine. And the test tube, or the flask in this case, felt hot compared to the start. The aluminum foil appeared to be disappearing, and it just left. There was a color change, and something else that was rusty or copper colored seemed to appear. The solution started to smell like chlorine because you were generating chlorine gas in this reaction. Any of these observations are great to have. So how did the aluminum foil change? Well, when you added to the solution, it dissolved. It literally dissolved to the point where you could no longer see it. Which type of energy is associated with temperature? Well, I'm hoping, based on all that we have done so far in our book, you'd realize that temperature is associated with thermal energy, or TE. Number 6, do you think the solution had TE in the beginning, and how do you know? Again, based on our discussions, I'm hoping that you'd realize that if something is not at absolute zero, or 0 Kelvin, then that means that it has some thermal energy. Even if it feels cold to the touch, it still has thermal energy. So for this, I said, yes, we know it has thermal energy because it's not at absolute zero. And also, our thermometer showed us that there was a temperature change. In this case, temperature change was 30 degrees Celsius. So there's definitely temperature, or thermal energy, at the beginning. And the thermal energy, I believe, was around 22 degrees Celsius in this instance for the average that I'm using. Did the thermal energy of the solution increase or decrease as a result of adding the aluminum foil? Well, it definitely increased by approximately 30 degrees Celsius. If we consider the solution in aluminum foil as a system, which type of energy in the system could be transformed or converted into thermal energy? Well, lesson 8 in our book right now is all about chemical energy, so it'd be fair to infer that chemical energy was transformed or converted into thermal energy. Do any substances disappear and or do new substances appear in this activity? And explain. The aluminum foil seemed to disappear, which it did. It was actually still in the solution. You just couldn't see it as aluminum foil as when you first put it into the solution. And a brown, rusty looking substance appeared, and the new substance was coppered. If you wanted to, you could also include that a new odor was noticed, and that was because you also developed chlorine gas. And then how do you know a chemical reaction occurred? Well, prior to this, we talked about signs of chemical reactions, and this one had several of those. So there was a color change, there were bubbles, temperature change. They're all signs of chemical reactions. The atoms of the original substances were still there, but they were rearranged to form new molecules and new substances. And since we assume that energy in the system is conserved, we look for an energy transformation that is the reason for the change in temperature, or thermal energy. The following energy conversion diagrams represent the energy changes. So we start out on the left with that energy conversion diagram with a lot of chemical energy and some thermal energy. We don't know exact quantities, but we do know there's more chemical energy than thermal energy in the beginning, based on our thermometer readings. And after the reaction, we noticed that there was chemical energy that got transferred, and not transferred, but transformed or converted into thermal energy. Again, we don't know the exact quantities of that. So during the reaction, chemical energy transformed into thermal energy that increased the temperature of the solution. So number 11 says, use the terms chemical reaction, temperature, and thermal energy to describe what happened in this investigation. And write this as a mini CER. Now, I wouldn't expect that you would write this much in your mini CER, but I wanted to write a complete thought type of answer for you. So my claim was, in this experiment, a chemical reaction caused the aluminum foil plus copper chloride to change into copper and aluminum chloride, causing the chemical energy to transform into thermal energy. That's quite a long claim. My evidence was, during the chemical reaction, the copper chloride solution changed color, bubbled, increased in temperature by 30 degrees Celsius, based on my average data, and gave off a vapor. The aluminum foil disappeared while copper substance appeared. And then my reasoning statement would be, the changes to the copper chloride solution indicated the copper chloride had changed into something else. A new substance was formed from the original substance. The new substance appeared to be copper, while the aluminum seemed to disappear. Therefore, a chemical reaction must have occurred. During the reaction, chemical energy was transformed or converted into thermal energy that increased the temperature of the mixture by approximately 30 degrees Celsius, on average for the data I showed you before. The copper chloride became aluminum chloride while producing chlorine gas.